Hello everyone. Today we are going to discuss about exercise 17.5 of mensuration. Exercise 17.5 of mensuration. This exercise mainly contain conversion. Conversion means from one geometrical shape to another geometrical shape. Maybe it is a cone and I am converting into the cylinder, or maybe it is a cylinder I am converting into a sphere. So during the conversion, mainly they are dealing with the volume. There are two type of words you will find here, either casting or by melting. Casting or melting, these are the two words you can get in this exercise mainly. When they are talking about the casting or melting, that means actually we are dealing with the volume. So always keep in mind, when there is a term casting from cone, I am casting a cone from to a sphere, that means I am melting the cone and converting into the sphere. And that means whenever I am talking about the melting, that means I am dealing with the volume. Now let's have some math so that you can understand. I'm taking the first one, totally first one. It is given, obviously the maths number may not match with your book. That is why I'm telling you the maths. Just mark it which maths I'm doing from your book. Number one, the diameter of a metallic sphere is 6 centimeter. The diameter of the metallic sphere is 6 centimeter. The sphere is melted and drawn into a wire of uniform cross section. The sphere is melted and drawn into a wire. Now basically, whenever you're talking about a wire, we take the shape of the wire as a cylindrical shape. What is that? A cylindrical shape. So obviously, I am melting the sphere and converting into a cylinder. If the length of the wire is 36 meter, find its radius. Length of the wire is 36 meter, then find its radius. So what are the informations I have? I have diameter of the metallic sphere is 6 meter. So diameter of sphere 6 meter, 6 centimeter. Therefore, radius of the sphere 6 by 3 centimeter, that is 6 by 2 centimeter, that is 3 centimeter. So volume of the sphere 4/3 pi r cube, 3 into 3 into 3 centimeter cube. Do not complete the calculation. Okay, never complete in this exercise. Do not complete this kind of calculations. I will tell you why. Now coming to the wire. Length of wire equal to 36 meter. It is 36 meter given. So obviously I shall convert it into centimeter. Then it will be 360 centimeter. Height is not given. Find the radius of the wire. Radius of the wire equal to r centimeter. So length of the wire is 360 centimeter and radius of the wire is r centimeter. As I told you, wire, whenever we are talking about a wire, we consider it as a cylinder. So obviously the volume of the cylinder, volume of the wire equal to pi r square into h. Again see, I am not completing the calculation. I didn't complete the calculation. Why? Because when I am melting the sphere and converting into the cylinder, I am melting the sphere and converting into the cylinder. At that time, obviously both the volume will be same, isn't it? Both the cases volume is same. So I add here, according to the problem ATP, 22 by 7 into R into 360 equal to, as I told you, in both the cases the volume are 7 because I am melting this one and creating this one. So that is why both are 7. 4/3 into 22 by 7 into 3 into 3 into 3. So 22 by 7, 22 by 7 both sides gone. Sorry. 3 from both sides gone. So what is left with me? It will be R into R and here this much. So it will be R square equal to how much? 2 into 2 into 3 into 3 by 6 into 6 into 10 into 10. So R is equal to, implies R equal to, if I do the root over of this one, 2 into 2 into 3 into 3 by 6 into 6 into 10 into 10, I will get 2 into 3, that is 6 by 6 into 10, that is equal to 0.1 centimeter. The radius is 0.1 centimeter. See there, I obviously reduced my calculation by cancelling both sides. That is why I told you not to complete the calculation here. Because in almost in all the cases of this exercise, you can find that we can find the maths of recasting. That means the volume will be same in both the cases. That is why I told you not to complete the calculation. Look at it carefully. Okay, so we are moving to the next one. Let's see what we have next. Next we have a maths, a solid metallic hemisphere. Okay, coming to the maths number 3, what we have is solid metallic hemisphere of radius 8 centimeter. Of radius 8 centimeter is melted and recasted into a right circular cone of base of radius 6 centimeter. So there is a hemisphere melted and recasted into a cone. Determine the height of the cone. So let's start. Obviously this is my hemisphere whose radius I think given, radius 8 centimeter. Basically in this exercise we do not need any drawing. We don't need any kind of drawing. Still I am just drawing it to make you happy. And this is my cone whose radius is 6 centimeter. And I have to find out the h. So radius of hemisphere 8 centimeter. As I told you, recasting, whenever we are doing the maths of recasting or melting, we will always deal with the volume. So volume of hemisphere, what will the volume? 2/3 pi r cube. 2 by 3 into pi means 22 by 7 r cube. 8 into 8 into 8 centimeter cube. Now radius of cone equal to 6 centimeter. Radius of cone is 6 centimeter. Height I don't know. Height of cone, I don't know. So volume of the cone, 1/3 pi r square h. That is 1/3 pi r square h. Unit will be centimeter cube because we are dealing with the volume. As I told you, I am melting the hemisphere and creating the cone. So in both the cases, the volume must be the same. So according to the problem, 1/3 pi r cube pi r square h equal to 2/3 pi r cube. I'm telling you again why the volumes are same, because I am melting this one or recasting this one into this one. That is why all the cases the volume will be the same. So again, pi cancel, the 3 from the bottom cancelled. So what is left with me? H equal to 2 into 888 by 6 into 6 into 6. This is left with me. We need to do the calculation now. 3, 3, 4, 3, 4. So this is my calculation. We need to calculate it. After calculating, we will get how much? Let's see. It is 1/3. Okay. It will be 28.49. 4 by 9. 28 whole 4 by 9 centimeter. Okay. So this is the output after getting the calculation. Look at carefully. Hemisphere, the volume of the sphere is 4/3 pi r cube, so it will be half of 2/3 pi r cube. So that is, I put it here. The volume of the cone is 1/3 pi r square h. So it is 1/3 pi r square h. After that, we make the calculation. Okay. So let's move to another one. I think you can understand now how this type of maths can be done. And as I told you, we don't need any drawing. We don't need any kind of drawing. If you want to draw, that is okay. But if you don't want, then it is also okay. Now I move to another one. Question number 7. Now moving to the next question number 7. It is given 8 metallic spheres. There are 8 metallic spheres of radius 2 centimeter is melted and cast into a single sphere. Casted into a single sphere. Calculate the radius of the new sphere. So in this maths, we are having both of them are spheres. But in one case, there are 8 small spheres and 1 big sphere. So radius of the small sphere. Radius of the small sphere is equal to 2 centimeter. It will be 2 centimeter. So total volume, I'm not wasting, don't want to waste time. Total volume of how many? 8. Total volume of 8 small spheres. It will be 8 into sphere, so 4/3 pi r cube. 4/3 pi r cube, that is 2 into 2 into 2 centimeter cube. 4/3 pi r cube, obviously, the volume of the small spheres. Now, we are moving to the next part, that is the bigger sphere. let radius of the big sphere or the single sphere, because I am melting these 8 spheres and creating only one sphere. So radius of the big sphere equal to r centimeter. So easily I can say, according to the formula, that is volume of the big sphere equal to volume of the 8 small spheres. So what is the volume of the big sphere? 4/3 pi r cube equal to 8 into 4/3 pi r cube, that is 8, 2 into 2 into 2, that is 8. So 4/3 cancelled, pi cancelled. So it will be r cube equal to 8, or r equal to, put the pi r cube, it is 64, it is 64. So r will equal to how much? How much, everyone? 4. R equal to 4. Because if we find out the square root of it, we will get 4. So r will be 4 centimeter. So the new sphere formed by melting the 8 small spheres. The new sphere is formed by melting the 8 small spheres. So the radius of the new sphere or the single sphere is 4 centimeter. Again, see, we are doing the maths of melting. We have done 3 maths around, 3 or 4 maths. But in all the cases, either we are recasting or we are melting. But all the cases, they are involving only one formula. That is the formula of volume. Nothing else. Next, move to another one. Let's have a big maths. Maths number 13. It's a big one. Though looks like small. A hollow sphere. Mind it, I am having a hollow sphere now. A hollow sphere of internal and external diameter, 4 centimeter and 8 centimeter. There is a hollow sphere having internal and external diameter of 4 centimeter and 8 centimeter respectively. Is melted into a cone of base diameter 8 centimeter. Now it is melted and we have created a cone whose base diameter is 8 centimeter. Find the height of the cone. Before going to that one, it is not written that the cone is hollow. It is nothing written like that. So obviously we will use the solid, we will use as a solid cone, but the sphere is not solid. It is a hollow sphere. So let's have the informations: diameter 4 and 8 centimeter. Math number 13 I'm doing. So again we have to do lots of calculation in this math. Internal diameter of sphere equal to 4 centimeter. So internal radius of sphere, it will be 2 centimeter. Now external diameter of sphere, 8 centimeter. So external radius of sphere, 4 centimeter. You have to write the informations like this. You are getting the maths and doing directly the maths. This is not allowed. You have to write the required informations. So volume of the hollow sphere. Volume of the hollow sphere is equal to 4/3. Then what? 4/3 then what? External radius cube minus the internal. External minus internal. So it will be 4/3 pi 4 cube minus 2 cube. External radius cube minus internal radius cube. Now coming to the cone. The radius of the cone is, the diameter is given, I am writing directly the radius. Radius of cone equal to, it is given 8 centimeter diameter given. So radius of the cone is 4 centimeter. Now I am showing you another way of writing this kind of maths. That is, I am not finding the volume of the cone. Directly I am writing according to the problem. I didn't find out the volume of the cone. No statement is given. Directly I put according to the problem 1/3 pi r cube 1/3 pi r square h means 4 into 4 into h equal to this one. 4/3 pi 64 minus 8. It will be 64 minus 8. Then it will be 56 into 56. Now pi gone, 3 gone. So I'm getting h equal to 56 by 16. 56 into 4 by 16. So I'm not writing 16. 4 into 4. So that I can cancel out these two 4s. So if I put it there, it will be equal to 14. So height is equal to 14 centimeter. Height equal to 14 centimeter. Okay. See, this is another way to calculate. I didn't find out the radius, the volume of the cone. In place of that, I directly wrote, according to the problem, volume of the cone is equal to volume of the sphere. That can be written as well. This is another way to write this kind of maths, so that we can reduce at least 2 or 3 steps or 2 or 3 steps of calculations. Next, we are moving to the next one, maths number 17. It will looks like a big maths, so let's have, we need to understand lots of things here. Math number 17. Let me write down the number first. You may not understand the language. That is why I am doing this one. A vessel in the form of an inverted cone. There is a vessel which is in the form of an inverted cone. So this is my vessel. Inverted cone filled with the water to the brim. Brim means total up to the upper part. The water is filled up to the upper part. Its height is 20 centimeter. Its height is 20 centimeter. And the radius is 8.4 centimeter. The diameter is given. I don't want to waste time. So that is, I am writing 8.4 centimeter. The radius is 8.4 centimeter. And the height is 20 centimeter given. 2 equal solid cones are dropped in it. Then I drop 2 cones inside the water. Okay. So that they are fully submerged. And immediately the cones goes inside the water. It is submerged. Suppose this is my 2 small cones here. One is here, another is here. But you can see it is totally submerged into the water. As a result, 1/3 of the water fallen out. As a result, whatever the water is there, if in the first, 1/3 of the water falls from the sides. It is fallen from the side. 1/3 of the water in the original cone overflows. That is fallen. Overflows means comes out of the cone. What is the volume of each of the solid cones submerged? Now I have to find out what is the volume of the cones that are submerged in it. So first of all, what we are going to do, height of the first cone. Height of the cone, I am not writing the first, I will use two terms. Height of the cone means the main one, and for the next case, small cones. I will write them as a small cone. I will not waste time writing the submerged cones like this. Height of the cone 20 centimeter and radius of the cone 8.4 centimeter. So volume of cone, or I can write down volume of water as well. Volume of cone or volume of water. Both are same because inside the volume the water is kept. 1/3 pi r cube, r square h. R square means 8.4 whole square into 20 centimeter cube. Now what is written? When I put two small cones inside the water, how much water is falling down? 1/3 of the water. How much water falling down? 1/3. So I wish I should not do, but I have to do the calculation. 2 equals always no drop, as in 1/3 of the water is falling down. So let me complete the calculation, otherwise you will face problem. 1478.4 centimeter cube. Now after dropping these two cones, 1/3 of the water falling down. So 1/3 of the total water, that is equal to 13 into 1478.4 centimeter cube. So it will be which mass I'm doing? 1478. Okay, so it will be 492.8 centimeter cube. This much water, or this volume of water is fallen down. That means this volume is equal to the volume of these two cones. This volume is equal to the volume of two cones. So 2 into small cone equal to 492.8 centimeter cube. Why 2 into? Because there are two cones. So if I want to find out one small cone, small volume of one cone or one small cone, which will be 492.8 by 2 centimeter cube, that is equal to 246.4 centimeter cube. So eventually it looks like a hard math, but I don't think it is a very big calculation. It is having a very big calculation or a very hard math. You can see there. So this is the way in this chapter we have to do the maths. We have done 5 or 6 maths from this chapter. But have you noticed one thing? Then in all the cases, we are dealing only with the formulas of volume, nothing else. So this is the way to do the maths. I hope you can do it. If you face any problem, just tell me later on. We have so many maths in this book, but most of them are very small maths. If you face any problem, we will provide you another video about this one of this chapter of the problem sums. Okay, till then, bye.